In this video, we're going to solve the equation, which has y equal to m times the quantity x minus h, where that x minus h is contained in parentheses, plus k. And we're going to solve that equation for the letter h. The first thing that we want to do is to identify which type of equation we're dealing with here. So this is a linear equation, but it's a little bit more than that. It's also what's called a literal equation, in that we're going to solve it for h. And still have variables and constants remaining. So it is a linear literal equation. When we're done, we won't necessarily have a number. We'll have an expression containing other variables and constants. So since it's linear and we're solving for h, we want to separate and isolate all terms containing h. And by separate, I just mean expand if necessary, combine like terms, and those things. So we will separate and isolate all terms containing h. So once we have all terms containing h on its own, we can then divide out any coefficient on h, and we'll do that to both sides. Okay, so let's get started in applying these. Well, let's take this y equals m times that expression x minus h inside parentheses plus k. We want to access h, but it's inside these parentheses where we have x minus h. So the first thing we'll want to do is distribute that m across that expression x minus h. That will give us y equals mx minus mh plus k. At this point, I can see that mh is the term that I want to isolate. So to do that, I want to just have mh on one side and everything else on the other. So I can get it alone on that right side by subtracting mx and subtracting k from each side. I very briefly moved where I was writing on the screen so that I won't run off of the recording area. So we will subtract mx and k from each side. We'll get y minus mx minus k on the left. And on the right, we'll have mx minus mh plus k, and then we will subtract mx and subtract k. So this will leave us with y minus mx minus k on the left and negative mh on the right. Now this negative mh, I want to get h on its own. I have negative m times h on the right, so I will divide each side by a negative m in order to get h on its own. So of y minus mx minus k, that's all divided by a negative m. That's equal then to negative mh over negative m. So now on the right, I have h all on its own. I am more or less done. Y minus mx minus k in the numerator on the left and negative m in the denominator. The only thing I'd want to do further is to move that negative. In general, we do not write a negative in a denominator. We write it out front of the entire fraction or in the numerator. So I would write this as the negative of that whole expression with y minus mx minus k in the numerator and just m in the denominator. So that whole thing would be equal to h. Or, if I really wanted to, I could move that negative to the numerator and do the negative of y minus mx minus k all over m, and that could actually simplify one step further to be negative y plus mx plus k all over m. All of these last three are considered fully simplified.